Aloha and welcome to ICS 314 Software Engineering. I'm your host for this semester, Philip Johnson, and I'm really excited about this class. This is my favorite class to teach. Students generally have a lot of fun and learn a lot. I learn a lot every single semester that I teach it. This semester is going to be no exception. I made a lot of changes to the structure of the class. So if you've talked with other students who've taken it before, you're going to find that this semester is going to be a lot different and I think even better than it was before. So anyway, let's get started. You can contact me, johnson@hawaii.edu. There's the course website at ics314fall13.wordpress.com. I have office hours Monday, Wednesday, 12:30 to 1:30, or really you can stop by any time that my door is open and see if I can talk almost all the time I can. You can also call me or email me to set up an appointment if you want to talk with me that way. Okay, I've been doing software engineering for a long time. Geez Louise, look at that. Even since the 1970s when I was using punch cards even to do COBOL programming. The 80s, I did some AI programming in Lisp, as well as some work for Ford Motor Company, helping build the compiler that they used for engine control. It was actually the first time a microprocessor was put into a car engine, so it was kind of cool. In the 90s, I was fortunate enough to move to Hawaii to become a professor here. I was working in Lisp and Java on software metrics. In the 2000s, I spent some time working on automated software measurement as well as software engineering for high-performance computing system, where I worked with Sun Microsystems on a next-generation HPC project. Last few years, I've been focusing on energy, sustainability, and gamification. That work's been a lot in Python and has been real interesting. If you want to talk with me about that, I'd be happy to do so. Okay, but for this class, what we're going to focus on is how to build high-quality, large software systems, and we're going to do that through an evolutionary process of growing a small, high-quality system into a large one. And I'm going to introduce you to this idea of a prime directive that helps focus you on the issues that count at whatever point you're in the development process of the actual system. And we're going to focus a lot on tools and technologies to help make your life simpler in the long run. Initially, all these tools are going to make your life a little harder because you're going to have a learning curve. You have to learn how they work. But after you learn how they work, you're going to be so happy that you know how they work because they're going to make your life easier. The other thing we're going to work on a lot throughout this whole semester is the idea of a professional persona. That's your online professional presence and is manifested through your online portfolio that describes the projects that you've done, a blog that you're going to keep this semester, and participation in various professional online groups like TechHui and LinkedIn. The idea here is that we want to establish a presence in the online world that's different from your Facebook page. Okay, your Facebook is a great thing. I even have a page myself, but it's generally not a good way to show potential employers what you're capable of. Maybe it's the exact opposite of that. Who knows? So what we're going to do in this class is develop an alternative online presence that you can provide to employers to help them assess your skills and capabilities. Okay, so I'm really focused on quality, and I think quality can be defined in a lot of ways. There's a really good book called Zen and the Art of Motorcycle Maintenance that you might want to read sometime if you're interested in a more philosophical discourse on quality. But I'm going to take a much more pragmatic view toward it. I'm going to say that a high-quality software system in a nutshell is one that's easy for users to use, easy for administrators to use, and easy for developers to use. Okay, this is pretty easy when it's a small system. As the system gets big, it's a lot harder to do, and that's why I have developed the 3 prime directives of open source software. Okay, and the notion is that it accomplishes at least one useful task, hopefully more than one, but if it can do at least one useful task, then we're okay. It should also be the case that a new user can successfully install and use the system. That's how you get more users to actually try it out other than yourself, is that you've built enough documentation or infrastructure into the program that someone else can actually use it. And then the third one, which is quite a bit harder, and many open source projects, quote unquote, they're hosted on GitHub or whatever, they actually fail at this, which is a way for new developers to get engaged in the development of your system. So if you can develop a system that does something useful, even if it's very minimal, if you can develop a system that you can get new users to be able to use and accomplish that useful task, and then if you can get a system that is sufficiently documented and sufficiently structured in such a way that new developers can actually jump in and make enhancements, then you're well on your way to having created a successful software project. Okay, so prime directive 1 is the system can successfully accomplish at least one useful task. The idea here is I want you to get away from the idea that you have to have the thing be complete, that it has to solve all the particular problems in the domain. Don't worry about that. If you can solve one thing, you're way ahead of the ball game. And oftentimes with open source software, it's actually good to release the software early when it doesn't do too much, because that makes it easier for other developers to get involved. There's not so much code to wrap their minds around. This also means that you should be able to at least get one useful task accomplished pretty quickly. And that means that the period of incubation where no one knows about your system yet is relatively short. It should be measured in days or weeks, or at the very most a couple of months before you've got something that you can give to the world that does one useful thing and they can start building upon. And getting this to be accomplished is facilitated by standards that enable this bootstrapping process to occur quickly. Okay? Prime directive 2 is that now that you've released this minimally functional system, another user can successfully use it. That requires some documentation, that requires standards so that users know kind of what to expect if they're trying to install it. And if they're trying to use the user interface, it should kind of work the way other user interfaces the way other user interfaces work that have similar kinds of affordances. And prime directive number 3 is the hardest one, as I said before, which is creating a system that other developers can learn to enhance. And that means a lot of standards. You should code in a particular style, design using patterns, use standardized technologies for packaging, provide tests, provide design level documentation, and so forth. And in all of these cases, you can't actually assess whether or not you're achieving any of these prime directives, but you need insight from the external community as to whether or not you're doing it or not. Okay, so we're always thinking about standards and feedback. That's going to be a recurrent theme in this class. I'm going to keep introducing standardized ways of doing things, and eventually once you understand the standard really well, maybe you'll decide to deviate from it or reject it entirely. But at least for this class, I'm going to impose some standards on you, and you're going to work to the standards so that you can kind of understand what it is that you're going to rebel against after you get out of this class. Also, we're going to try to introduce a lot of different kinds of feedback to help you move along as quickly as possible. Okay, so here are some of the standards for coding, package structuring, engineering, reviews, and tools. Feedback's going to come from other folks in the class, from me, from the mailing list, from tools, which will give you a lot of feedback, and hopefully from the outside community. There are 3 texts for this class. The first one, Thinking in Java, is kind of an optional text. This is one if you don't feel that strong in your Java programming skills, you've been away from it for a while, you want a refresher or whatever. I think I've looked around, this is the book that I think is the best one for getting you up to speed. $25 is an ebook. You can get it online, download the PDF. He has previous versions for free. I recommend against getting the previous versions. I recommend getting the best versions. So fork over the $25. It's just the cost of a pizza. If you feel you need it, what you can do is download the sample chapters first, read through them, and if it all looks very trivial to you, then maybe you don't need this book. Okay, and as you run into Java issues, you can just Google around, go to Stack Overflow, whatever, and figure out the answer. Second book, which you will need to get, is The Elements of Java Style. That's $10 as an ebook. A great book on how to, kind of write code and structure it in a certain way and avoid various pitfalls. The third book is called Play for Java. It's under development. Not even all the chapters have been written. When we get to the Play framework, I'm going to recommend that you buy this book. It's $40. It needs a lot of editing still. I'm not really that impressed with it, but that's the only book that's been published or even under development for the Play framework. So I think it will speed the learning curve. It's a little expensive for what it offers, at least at this point, but I am hopeful that there'll be a new release before we actually get to that point in the semester, and that it will, it'll be a good investment for you. Okay, so for this class, you're going to need some decent Java programming background. If you have not passed ICS 211, you should not take this class. Please drop it quickly so that someone else can get in. If you haven't passed 211, I will administratively drop you from the class. So you need to have done that. If, on the other hand, you're just coming into the program, or you're transferred and you have at least 1 year and written a system that's 1,000 lines of code, then you've probably got enough Java programming background. I vastly prefer Unix and Macintosh as the development environment, although if you have to use Windows, I guess that's okay. Use XP Pro or 7, maybe 8. I don't know that much about 8. You're going to want a fast network connection. Obviously, all of you will have that. Lab and TA machines are not valuable because you're going to need to bring your laptop to class. So you need to have a laptop. The final thing is that you're going to need a lot of time. And I'm sorry about that, but the only way you learn to program is by spending a lot of time doing it. And so I'm unapologetic about the fact that this class takes a lot of time, because there's no way to do it if you're just sitting around every couple times a week spending an hour or two programming. It's not going to happen. So don't take this class if you're taking, compilers and operating systems and networks. Give yourself a chance to succeed in this class by giving yourself the time to actually spend the time to make mistakes and, kind of program your way out of them. Okay? So a laptop, any kind of modern laptop. Don't get a netbook. Don't get you can't do this class on your phone or on a iPad or whatever. You're going to need, kind of a basic laptop functionality, and they're not that expensive these days, and you'll want them. You'll profit from having a modern computational environment. Grading, about 30% on the quizzes, 20% on the final, 15% on the programming assignments and homework. If you get 90%, you're going to for sure get an A, 80% for sure a B, 70% for sure a C. If things turn out to be a lot harder for you than I thought, then I might adjust it down and make 85% an A. But I will not adjust it up to make 95% an A. So it is possible for everybody in the class to get an A. You're not competing. There's no bell curve. I'd be delighted to give everybody an A. It just means that all of you have to do really well in the class. The way this works is we're going to have lectures available as screencasts. The class time will be labs in which you do software development and other kinds of exercises. You need to always watch the lectures and read all the materials before the class period that's associated with the topic. Okay, so when you see like module IDEs on the calendar page, you need to have done all the preparatory material for that module before that day in class. I'm going to expect and potentially quiz you on that material. Quickie quizzes. The idea is before I say each Monday, but it could be really any day. I have a short in-class closed book quiz on the current module. It's generally a very easy question, provided you have listened to the lecture and have really thought about the material. This helps me understand, where you're at. It helps you by giving you an incentive to actually keep up with the material. This is a writing-intensive discipline. This is a writing-intensive class. And so you will be doing a lot of writing in the class. I will, as part of this professional portfolio, you'll have a blog section of your professional portfolio where you do a lot of short technical writing articles about various topics, and this provides something that future employers can look at to get a sense that how well you can write and what your skills are. Okay, so as I talked before, I want you to develop a professional persona, some kind of online presence. It consists of a log, a portfolio, open source code, participation in professional networking, and is something that you'll start in this class and then continue on, for much of your career, I assume. Now, I like there to be collaboration in the class. There's a lot of group work. I like you to talk to each other. I like you to work on assignments together, but I don't like you to cheat. Okay? Cheating is pretty easy to find. It's basically taking someone else's work, either code or writing, and submitting it as your own. Okay? Even if you do some minor rewriting to try to disguise the similarity. Okay, that's cheating, and the consequences of that will be very, very as severe as I can make it. The reason being is there's absolutely no reason for you to cheat in this class. Okay, I want to encourage you to talk with each other. I want you to encourage you to help a classmate debug one of their errors, by looking at their code and suggesting things they can do and suggesting code that they can type in. That helps. That's as interesting and as good a learning experience for you as it is for them. If you're working on some system and you find some code on the net that you can use, you can reuse it as long as there's appropriate licensing. You just have to attribute it. You have to put in a comment saying this is code from foo, and under this particular license. That's all fine. Okay? If you're not sure whether or not a certain thing you'd like to do is collaboration or cheating, you're not sure which one it is, then just ask me about it. Okay, and I'll tell you, no, that crosses the line, you can't do that, or sure, that's fine, that's just collaboration. All right, so far it's been pretty good in this class. I haven't had much of a problem with cheating. I'm hoping to keep it that way. Cheating's not good for your learning situation, and really the time you spend cheating would be much better spent collaborating. So just make sure it's that way, please. Okay, so people learn things in this class. One of the things they learn is to start early. You can see some quotes from former students. Waiting to the last minute to code is not a very good idea. Okay, testing actually helps. This is kind of one of the epiphanies that you learn, is that testing is a good thing to do, even though it doesn't seem like it's code that's actually kind of implementing the functionality. It's great to learn to read code, and you want to read a lot of it. You want to actually follow the standards that are proposed, mainly because as people start to realize, when you follow standards, other people can read your code really quickly and easily, and it takes them less time to get to the point that they can actually help you. So it's a readability issue. Some of the things in class may seem at the moment that you're learning them like they're a waste of time or they're creating extra time. And many folks kind of suggest that you should suspend your disbelief about the recommendations in this class, that you'll understand. If you don't understand it immediately why they're of value, you will eventually. This person was very confused about what they were doing in ICS, but then they got into ICS software engineering, and the clouds parted, the sun shone through, and everything was awesome. So that's what I hope all of you will experience in this class. On the other hand, some people don't have that experience. This person said that even my ability to actually teach is questionable, and to that student I continue every semester to issue this heartfelt online apology that I somehow created such a disastrous educational experience for you. Again, I apologize. I'm trying not to do it. I'm trying to learn from my mistakes. So hopefully none of you will have that experience this semester. Okay, so go to the calendar page to find out when modules and assignments are due. Again, you have to have studied the resources associated with the module by the day it's listed in the calendar. That's not the day you start looking at that stuff. That's the day I expect you to have actually completed that part. Okay, so go through the website, look at all the pages, start work on the introductory module, and have fun.